NY. Very actually. Our project is the war nickel detector. In order for you to understand the significance of our project, you will need to understand a hobby called coin roll hunting, or CRH for short. CRH is a hobby where coin collectors like myself, Andrew, Jason, we go to the bank, purchase large volumes of coins. And what we do is search these coins for valuable ones. And these coins have value based on metal content. That metal is mainly silver. You're not going to find any gold anymore. And value based on rarity. Here's an example of what to look for. These are Benjamin half dollars, 90% silver, minted between 1948 and 1936. Currently, they carry a value of $10.50, only from metal content. All right, so this is our target denomination that our device will be searching. These are war nickels. They're 35% silver. These are different than your nickels you carry in your pockets. They're, as you can see, they have the mint marks above the dome of Monticello.
That's
the Capitol building.
That's Jefferson's group.
And it's PDNS for Philadelphia, Denver, and San Francisco. Like I said, they're 35% silver, minted between 1942 and 1945. Now, these are the drawbacks of CRH. It's very time-consuming, very tedious. Jason, Juan can vouch for me. He searched a whole box together, and he gave up in 5 minutes. So, we have decided to build a device that searches this completely automated using computer vision.
This isn't a way.
Yeah.
I don't like your models.
Alright, so this is our war nickel detector. What it will consist of is the coin feed system. You will see it in a few seconds. Microcontroller, image capturing system, and a computer vision library, which is OpenCV. Jason will tell you more about it in a few minutes. This is the stepper motor we're going to be using. Very easy, 1.8 degrees per step, 12 volts. Servo motor, that's going to control our trapdoor, which is the slot we want to accept these war nickels in. I'm going fast. It's big run. 2 minutes left. Okay. So this is a motor shield from Adafruit Industries. Basically, this and the Arduino that you're going to see in a few minutes, it's going to facilitate for lighting, stepper control, and servo control to operate the trapdoor. This is our Arduino. This is our main input capturing device, which is IPEVO is a document camera, which teachers use to do read-alongs. 640 by 480 resolution. So this is what we'll be using for computer vision. OpenCV, which is a library that consists of 4,000 functions. Some of the functions that we'll be using for our application is grayscale conversion, histogram, and action section.
So to begin with image processing, we need a grayscale, take an RGB image and convert it to grayscale, as you see here. RGB standing for red, green, and blue. The reason why we have to do this is because RGB, each color is a channel, and to do image processing on a color image, you would have to mess with each channel and check each channel individually, and that's too much work. And color normally doesn't really have anything to do with, or is not the important aspect of image processing.
I'm sorry.
The important aspect of image processing is edge detection, features, corners, and basically lines, circles. To do this, we will take that grayscale image, which consists of one single channel, so it's more convenient and easier to do whatever checks, edge detection, as we see here, using the candy method. Basically, we chose this method because it's, as you see here, the edges are, it looks like a real nickel. You can see that it's a nickel. unlike there's these other methods, Sobel, Hewitt, the method of those, edge detection is somewhat, it gives false lines due to noise or light
Limitations on
scratches,
hardware.
yeah.
What is the algorithm that you use to
Your algorithm, sir.
We're
No,
gonna
no,
explain,
no,
we're gonna
no.
explain our audience. So basically,
I'm just telling you speed up.
so basically, in order to detect for a war nickel, we use I think an algorithm called region of interest, where it takes the left end region, the right region, and the center region, and we do checks on those based on the pixel count. If the center region has a certain
Just
amount
where
of
the mint
pixels,
mark would be
non-zero
located.
pixels, yes, has a certain amount of non-zero pixels, meaning white pixels, then it's a war nickel. If it's not, then it's just a regular nickel. To do that, we have to rotate the image because it's not always upright. And basically, we made a function using OpenCV library.
Which Jason built.
And we rotate the image until it gets into the upright position where we want to check our regions. But to do that, to get it upright, we have to check for we have to do another check using the whole line transform. We detect the lines in the image under the Monticello. We determine that the Monticello has a straight line edge right here, and we use this transform to draw a line and check a line, draw a line, and check it, see if there's a certain amount of pixels. If there is, yes. If there's a certain amount of pixels, then it's straight up, and then we do our checks, left region, right region, center region, and if there's something in the center region, then it's a war nickel. If it's not, then it's just a regular